Okay, so now we'll go after this capacitor here, which according to the schematic is a 120 microfarad or 120 nanofarad, and I don't have exactly that, but I have this guy. He's a what? Instead of a 120, we'll put in a 150. You know, it's just grounding out some stuff. So I'm not too worried about it. I think this is a ground here. Wow, ground. Just about everything's grounded on that too. So we'll clip that guy out of there. You know, I got a small one that will go in there. No, I did not have a little teeny green one. I have to put the bigger yellow one in there. Snip out. Out you come. Cracked. Hey, what's that say? Yeah, 120 A, I think is what that is. And we're going to put in a 150. Not much different, really. It's funny how I've done so many radios using the standard capacitors that I have, and I run into this one, and there are so many different values. I'm wondering, is it the manufacturer, General Electric? Is it the vintage? This is a vintage I don't work on that often. What is it? There we go. Get rid of some of that. Whoops, whoop. Drop my solder. And another one is done. Whoops, dropped that. It's hanging in this dust here. Oh, I heard it fall further. I think I heard it fall right through the hole. Oh no. Another wandering piece. Hey, maybe this guy's next. Yeah, I think the piece went through the hole there. Okay. Yeah, what about this one? So that's coming from, it's grounded here, don't be fooled. It's not connected to the tube, it's simply grounded at one end, and the other end is on this IF. This is the, I believe that's the second IF coil. So we'd be looking at some capacitor off of this coil going to ground. That one there? It's a 180. 180. I don't have a 180. Crying out loud. This thing here, it's a 180. It's, no, wait, whoa, what am I doing here? I'm losing sight of what I'm looking at. Here we are, over here, 180. The high side is connected to a resistor, a 22K resistor. It could be that. Yeah, 22. Not 22K. 22. That doesn't look like 22K. Looks like 22 with a green there, like 22 meg. Is there another resistor in here with a 22 on it? How does that work? Let's take a little reading there. This is across a coil. 20, where'd it go? Where did it go? How quickly I do get lost. There it is, 22K. No, it's not across any capacitor. It's not to ground either. What am I talking about? Yeah, 22K. 22K. See that? 22 megohms. 2 megohms, just a hair over 2 megohms. That's a far cry from 22K. Let's see, there's another capacitor connected to the high end. Let's see, there's a resistor, and then what is that? It's a wire that comes way down here. I can't see it under this big honking capacitor, so you know what goes on here a lot is just trying to convince for me anyway, is trying to convince myself I know what I'm doing before I do something. So we come to the other end of it. Well, it's to ground, so there is no other end. This has to be it. Because the ungrounded end goes to the plate. Okay, so the ungrounded end, oh shoot, goes to the plate of this tube here, I believe. So let's follow from the plate. The plate is where is the plate? The plate is on pin number 6. Okay, so that's 6, so that's 876. So this is the plate here, I think. Anyway, coming right out of this transformer. That looks a lot more like a heater. Maybe I counted this wrong. Okay, so yeah, so there's the little nubbin. So 8, 7, 6. So 6 is this one. And it's got this capacitor here. So this might be the 120. Okay, so what's going on with this thing? It's not even this thing, it's this thing. Oh boy. Going back to this. Maybe it has the size written on it. Wow, what a whack of dust. The dust must come in through that hole, have come in and settled on the top of this capacitor, coming through that hole. The same sort of thing on this one. The dust has come through that hole and settled on the end of this thing here. Isn't that something? Now, where are we? Okay, so we're looking at the end of a 22 megohm resistor for which we cannot find a match on the schematic, but we see a 22K. Here's a that's interesting. Okay, so it goes to this line here from the resistor. The resistor, do they show the shielded cable in some way? They probably do, and I'm not spotting it in here. Oh boy. Okay, let's refocus again. Let's go back to this. And let's do our best to identify what this is here. And it looks like a number or a letter on there. Does that help at all? Hey, look at that. The coils have letters on them. C, G, H, and D. Okay, so that looks like A, B. That would make this C, D, E, F. What do I see there? That looks like a D. It's very hard to see these letters. I'm sure they're not coming up in the camera. Not with me putting that there. Look like a D buried under there. It does look like a D. A, B, C, D, E, F, G. Yeah, that looks like a G. E, F, G, and H. That looks like an H. Okay, so that's great. Whoops. Hope I didn't blow your ears off with that. I'm getting so excited here. So going back to this coil. Now we can see the 180 is on D. A, B, C. Come on, there's nothing connected to D. Look at it. It sure looks like D. What? Well, what if they flipped it around and they did it off a G? Maybe this is flipped around. So that means this guy would be connected to G. Okay, this capacity. No, he's on B. B, 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 B. Okay, so let's look at B and see what's there. B. And there is no B. There is no B. There is no B terminal, but there's a bunch over here. C, H, D, G. C, H, D, G. Why are there even any more connections to it? It's basically, oh man. So A and D are left out of the circuit. A and D. So A and D. A and D don't. Oh, D does appear right there. D. How come there's an F there? What's that? F. Oh, this isn't helping at all. This is just causing even more confusion. Okay, so F is grounded. So F is grounded. That's interesting. Okay, so F, B, C, D, E, D. D has nothing on it. Come on. Oh my, they wired the radio wrong in the shop when they built it. Oh my. Probably never worked a day until now. Now it's in my hands. I'll just change all this around to match this diagram, and then we'll have it working perfect. Right. It's starting to remind me of my work on my furnace yesterday. And all the trials and tribulations I went through. Man alive, you know, the simplest things become complex. So let's trace this wire properly here. I'm going to put my ohm meter on the tone. And what we'll do is we'll try to find out where this wire goes. From the other side of this capacitor, right here, where do you go? Disappears in a wire that appears to be this yellow one, maybe here. I get a good contact on there. Bingo. So that wire is going over to the other IF and also carrying on all the way up to here and all the way up to here. So that's a very busy wire. Doesn't look busy on this circuit diagram though. It has one capacitor, another capacitor. You know what? I'm not getting this right, I'm sure. Phooey, phooey, phooey. Okay. Once again, taking the simplest things and making them nearly impossible. Well, what other capacitor is grounded in and around this IF? Or am I totally ass backwards here, and this is actually the first IF? How could that be? If this is the first IF, and I've just got my head so turned around here. Hey, does that appear on that diagram? The tube diagram, let's take a look here. Well, the two IF, they appear, but they're not labeled. So that didn't help. So let's think about this now. The output tube is, the output tube's here, the tube driving it is here. I mean, this just makes sense that it just tracks back through the radio like that. It really does. So it's far-fetched that this one is not the second IF as we've been studying in this diagram. Yeah, some resistance measurements in there too, which is handy. In case we determine one of these coils is open. I hope that's not the case. I hope. No, okay, let's try and spot this great big high wattage resistor. Maybe this will give us some reassurance. And that would be coming off of pin, what would be pin H. H. So show me a, how am I going to spot a high wattage resistor? the value of which I didn't even see. Hey, you know what? It's coming. This resistor is coming where I attached that other resistor. So that's the multicapacitor point, and that's the resistor coming into it, the one I replaced, and connected to that same point. What? I don't see it. Uh-oh. I'm starting to have that feeling that the schematic doesn't match the radio. It certainly is the right one. KL-70. KL-70. Have I gone crazy? KL-70. I'm not crazy. I am not crazy. KL-70. It's basically a resistor between this tube and this coil. And on the diagram here, I don't see any such resistor between this coil and this tube. Okay, now wait, I got something a little mixed up here, eh? Output tube, this would be the 6SQ7, this would be the 6SK7, back here. So this guy's looking at the primary and this guy's looking at the secondary of this coil. So, getting my head a little bit straightened out here. Now, I'm looking for the resistor from this to here. There's a big one. Okay, that's probably it. 10,000 ohms. High wattage. Let's see what the resistance is of that. Is it 10,000 ohms? No, it's 9.9. Phooey. Yeah, that's the 10,000 ohm resistor. Okay, so that's this guy down here. And one side is connected to point H. Yes, it is. And then between H and C, there is a capacitor. Between H and C. I don't see any capacitor in there. Yeah, right. Oh man, you think you get it and then right away you think you don't. Well, let's do some pin counting here. So C goes to this pin. C on the coil goes to this pin. And that pin is pin number 8. And so C on the coil goes to pin, there it is, pin number 8. Perfect. Okay. Okay. So there's no doubt that this coil is this coil. See how easy this is? Man. All I'm trying to do is figure out what is going on with this capacitor here. So it's connected to the coil, position B. See, position B has the 22,000 ohm. It's D. 22 D. See, it's starting to make a little bit of sense. Like this 22,000 ohm resistor is probably this 22 million ohm resistor. And right off of it is this 180 nanofarad capacitor. Because, you know, maybe some of these terminals aren't even used. Like this might not even be used. This might just be an open terminal. A, B, C, D, E. For instance, E doesn't appear in the diagram anywhere. So this resistor then just connects to this wire, which is heading for that upper coil. So let's try that. That resistor heads to this wire. Look at that. Look at that. Down here, down here. See that? Shows it's a shielded wire and it goes to this plug. Plug arrangement. I believe that's that looks like a switch the way they've shown it, but maybe they don't show the actual plug and connection between the switches and the okay, so I was feeling happy there for a moment. Well, what happened when I took my eye away? I was so excited because this 22K really looks like a 22 mega ohm resistor here. And off the top of it is the 180 here going to ground. So there we are. So this is definitely it. This is a 180. I don't have a 180 after all that. What would that be similar to? Okay, 180. It's going to ground, so I don't think its size is that critical. 180. So that's like a 0.002, which is close to that. 0.002. So I'm digging around in there. There we are, 0.0. It's not quite the same. This is a 0.02. And that's a point. This is 002, and that's 0018. That's pretty darn close. Man. Yeah, you know, I don't know. I'm testing the capacitance of this on my meter, and I don't know. It said 1.6. And I'm thinking this is a 2.0. Let's just review everything once again quickly here before we decide to do this. So we're talking about this capacitor right here. .0018. So I either go 0.0015 or 0.002. Let's go 0.002. Let's get it done, man. Really. 0.05. Okay, now what? Now what? See, it might just be the size of the capacitor is hardly critical in those positions. As long as it's bigger than a certain amount, it can be as big as they want, it'll do the job. As long as it doesn't go a little too small. So they put in a 0.05 instead of a... That's a big difference, man. Wow. Okay, is there a 0.05 that I'm confusing with this situation? There's one way over here. Oh my lord. Way over here on the other coil. There it is, right in the position. Going D to ground. No, that's not working. D. Oh my lord. Well, best thing I can do is just put a 0.05 back in there. Am I crazy? Does that really say 0.05? It sure does. I mean, it's a big thing too, right? It's a big capacitor. Physically big. 0.05. Okay, let's put in a 0.05. The thinking here is that whoever did this before knew what they were doing. However, it got to be that way. Could be a lot of wax on this wire. Could be a lot changes, production changes, not reflected on the schematic I have. Certainly looks like an original capacitor though. That's a really messy wire. Hopefully that wax will melt out of the way. Ooh, it's another case of the leads being too short here too. Oh, of course it's going to ground here, right? So it's grounded here because of the size of the capacitor, so I can ground it right down here. Yeah, sure. That's no problem. No problem. No problem. Sure hope I'm not making a mistake. You see, one of the principles in doing this kind of work is to get the radio working a little bit. And then as you make changes like this, you monitor, you test the radio and see, is it still working? Has it gotten better? Has it gotten worse? If the radio's not working, and you start doing this, you could be introducing problem after problem and not really know it because the radio's not working anyway, so you can't really test what you're doing until you get everything done. And then at that point you might as well bring out the cry bucket because you're going to have to go through everything you did and double check it all. Yes, second time around is faster because you've reasoned through everything, but there's a very high likelihood you will make the same reasoning error and end up simply verifying your mistake as being valid. And then you go around and around and around and around and around. And that's exactly what could happen here to me. Ooh, where'd that little piece of wire go? Another flying piece of wire gone in there somewhere. So I think that's going to be it for now. Better mark off that capacitor. sure it was this one. I should really write the value in there too. 0.05. Oh, for crying out loud, I wrote it and pointed at the wrong thing. How many ways can you know, there's only one way to go right, and there's like a million ways to go wrong, so. 0.05. The D terminal. It's not. Okay, leave it alone, Jimmy. Drive yourself nuts. I'm already half nuts, and I don't really want to go all the way to full nutsiness. Okay, well, thanks for watching that crazy affair, and I hope I'm not driving you nuts with my logic going around and around and around. And I am trying to get a little bit of actual work done. So we've got 1, 2, well, I can look at my diagram. We've got 1, 2, 3, 4, 5, 6 capacitors done. 1, 2, 3, 4, 5, 6. 6 capacitors done, and a couple of resistors along the way. So we're about 20% through the work. That's it. See you in the next video.